Okay, this hour we are going to introduce actual HTTP web HTTP protocol. But before doing that, we still need to mention something about the underlying transport protocols. The actual, of course, there are many different therefore transport layer protocols, but nowadays there are only two protocols used in the internet quite often, which is TCP and UDP. And I believe you already know what TCP is and UDP is. Okay, and let's use the information we provided in this page. Okay, tail integrity, timing, throughput, and security to explain the difference between TCP and UDP. Okay. First is I think the most difference between TCP and UDP is the way they transfer messages. And as we mentioned before, there are some applications they need the message to be transferred in a way that every byte, every bit, and the order should be exactly the same. For example, if you create a socket by using TCP, the message is transferred from the socket. The every bit transferred from the sender socket will deliver to the receiver socket one by one. Every bit will be exactly the same. The order will be exactly the same. No any bit will be lost. Something like that. Okay. So the difference is that the TCP service provides reliable transport between the sending and receiving process. However, the UDP can only provide unreliable data transfer. So that means when you use UDP socket, the socket might lost packet, might out of the bytes sent and delivered might be out of order. Since this TCP needs to make sure that every bit is correct, they are in order. So the operating system, the TCP program and the operating system at the sender and at the receiver, both of them should negotiate some very complex parameters or some actions to guarantee the reliable data transfer is guaranteed. Okay, but UDP service, the UDP program in the operating system at both sides, they don't have to do so. Okay. So the next two things is flow control and congestion control. The flow control means, for example, the host, okay, the host of the sender and the receiver, they might be different. For example, the host might at the receiver might be a very old host machine. So the memory, the CPU, the bandwidth should be might be very limited. But the sender, its CPU, its memory, its bandwidth might be very nice. So when you send a large amount of packet from the sender to the receiver, maybe the receiver cannot receive such large amount of packets. So the underlying operating system at the transport layer should negotiate with each other. The operating system, the operating system at both sides, they need to negotiate with each other to make sure the packet sent from the sender will not overwhelm the receiver. Okay, so again, congestion control is maybe the intermediate routers. They might be very busy. Their queue might be full, something like that. So the sender should not send packet too quick. because if the sender send the packets too quick, the buffer, the queue might full, and it may cause data packet loss. So the sender should control its sending speed. Sometimes it needs to slow down its pace when sending a lot of packets to avoid congestion. So there are many different the mechanisms. We will talk those mechanisms later. Okay. So when you see connection oriented, this word in textbook, that means TCP. Okay. So when you see connection list, that is UDP. Because the operating system of TCP should have certain mechanism to deal with reliable transfer, to deal with flow control, congestion control, etc. So when connect the socket using TCP to connect the socket, there are several call setup need to be done. They are required between the server and client to make sure they exchange certain parameters before the communication starts. They have exchanged some parameters for flow control and congestion control, etc. So TCP need setup before sending actual message, but UDP don't have to do so. So it is connection-less communication. Okay. So next part is timing and throughput guarantee. As we mentioned before, because we use packet switch, so the delay is not guaranteed. So the timing and the minimum throughput guarantee are not provided by TCP and also UDP, because the underlying infrastructure cannot provide such kind of services. Okay, and as we mentioned before, if you need some security mechanism to encrypt or compress data, you have to do it by yourself at the application layer. Okay, so at the right hand side, UDP does not provide reliable data transfer, and it does not provide reliability, flow control, congestion control, timing, throughput, security, and code setup. So basically, UDP does not provide any services for the upper layer, but TCP has reliable transfer, flow control, congestion control, and code setup. Okay, so we have the simplest one, which is UDP. We have a more complex one, which is UDP. It depends on your application. So here we have a table right here. So take a look at this one. We will introduce HTTP in this hour. Okay, so that is a TCP, because we would like to transfer web documents, and those documents should be reliable under reliable transfer. So that is web. Some quick overview, but I believe you already know those things. Of course, web pages contain several objects, such as HTML file, JPEG file, applet audio file. And web pages consist of base HTML file. For example, the very first page you receive from the web service should be a HTML file, and it should contain several reference objects. And each reference object has addressable by a URL. That is an example, but I believe you already know those things. A URL should contain a host name and a path name, which indicate which files that the server should reply back to the client. Okay. So HTTP is a client-server model. I believe you know that. So the client is the browser that requests and receives those web objects from the web server by using HTTP protocol. And further, the browser, after the browser receives an image, it should display the image on the screen, right? But displaying is not defined by HTTP. It is not HTTP's job. HTTP only define the format, the actions, the syntax, the semantics when they transfer the message between client and HTTP server. After the client receive those objects, for example, those images, those files, those MP3 files, and when do rendering or displaying, that is not HTTP's job. Okay, that is browser has a rendering engine to display those multimedia files, but HTTP only deals with the communication itself. Okay, server, web server sends objects, of course, using HTTP protocol in response to the request. Okay, so some other thing right here. Since we need to send files, so inevitably we can only use TCP because we cannot miss any single bit when receiving files, right? There are 5 steps right here. First, server should listen at port 80. So for example, we have a client right here and the server right here, and here's the port, right? Server should use port number because HTTP use this well-known port number. So usually server will register port number 80 from its operating system. Okay, but the client right here, the client can use any arbitrary TCP port number, any arbitrary one. Okay. Step number 2. When server listens at port number 18, and then the client will initiate this TCP connection to create a socket. And of course, as we mentioned before, the actual communication should go down to the layer 1 and then go back to layer 4 and layer 7. But conceptually, we can say that these two, server and client, they communicate with each other by using the underlying ports, the underlying socket. Okay, so number 1, 2, 3 means server listen and client initiate it, and the server accepts such kind of TCP connection. So that is set up that we mentioned before. Okay, that is set up. Before you send any message, you have to connect these two sockets and exchange certain parameters. Okay, so that's set up. And step number 4, and the client can exchange messages between the server and client. Okay, so the message can goes down right here, and it will goes up to the server, for example. And of course, the reply message goes down to the client, goes down to the socket, and then goes back right here. So the client can receive the response message, which is a light green one. Okay, so after that, the TCP connection closed. So the socket number will be the socket will be closed. All the resources associated with this socket will be released. Okay, so that is the basic operation of HTTP. Okay, at the right hand side, we would like to introduce one word, which is stateless. Stateless means after the 5 step right at left hand side, the server maintains no information about past client requests. That means they create socket and they send request and reply the response and then close the messages. The server will not remember anything about such communication because right here, because remembering the past communication is very expensive. That means you have to spend memories, CPUs, storages to remember at certain moment some client has sent certain messages. to me, and then I reply certain message back to the client. It is very expensive to remember such kind of things. So in HTTP, they are quite old layer 7 protocol, right? So they decide not to remember all those information. So we call those such kind of protocol as stateless protocol. Okay, and that is very complex. That if you really want to remember this past client request, okay, you have to set up several database, several memories to remember all the things, and also if two peers, they both remember such communication, right? But what if one of the peers crash, or one of the peers I don't know, has some problems, okay? If their status or their state is asynchronous, for example, one server crashed, so after the crashed server reboot, they may not the crashed server may not remember the state before it crashed. So client says, okay, we are trying to communicate with each other, sending some files in the middle of sending, and the server crashed. So the status at the server and the status at the client may not be the same, which I mean not synchronized. So that would be very complex to recover those state for that crash server. So that is not a good idea to maintain such kind of stateful information in the protocol. So most of the old protocols, they are stateless protocol. Okay. So here some history. Okay, HTTP has old version, which is HTTP 1.0. The other is HTTP 1.1. We call it non-persistent HTTP and persistent HTTP. So let's take a look at the figure, which is good enough. Okay, we have a client right here, we have a server right here. So the server listen at port 80, right? Listen at port 80 and wait for client. And the client right here, okay, it initiated the HTTP client to the server, of course, with the help of operating system, which means it calls some library to initiate such kind of connection, okay, to port 80. So after that, they set up the socket, and the socket is connected. That's okay. And then for step number 2 and 3, they start to exchange the messages. So the client sends a request message, and the server responds the response message. So it's step number 2 and number 3. Okay. So after step number 3, okay, after they exchange all the messages, okay, the HTTP server will close the TCP connection because there's no further message should be exchanged between the server and client. So the server will close the TCP connection. Okay, so that is so when the client receives the response message, usually, okay, for the first web page, it should be HTTP. Sorry, it should be a HTML file, right? It should be a HTML file. So that is, although they are after parsing the HTML file, there might be some 10 extra referenced JPEG object should be downloaded from the server. But in non-persistent HTTP, HTTP 1.0, everything stop right here, because the TCP connection has been closed by the server and as well as by the client after it received the very first HTML file. Okay, so what else we should do? Because we have 10 more reference JPEG file need to be downloaded. So Step number 6. The client and the server will again negotiate a new socket pair to download the next reference JPEG object and then close it again. So it has 10 more objects need to be downloaded, right? So the server and client will create 10 additional sockets. So repeat step number 1 to number 5. And as you can see, only one object will be passed from the server to the client in a single HTTP connection. Because the server will terminate the TCP connection every time it finishes transferring one object. So that is called non-persistent HTTP. Okay, so as you can see, this is not quite efficient, right? So here we have some mathematics right here. So take a look at the right hand side. Okay, the blue part. Okay, the server and client will negotiate with each other to set up the TCP connection, right? So it takes some time right here. We call it RTT, that is round trip time, right here, round trip time. It is a time for a small packet to travel from the client to a server and go back. So this time span is one round trip time, and it takes one round trip time for the client to server to establish the TCP connection. And further, for the blue part, the client will request resources from the server. So it sends HTTP request message from the left-hand side to the right-hand side. So after that, the server will send the HTTP response message carrying the, for example, the image, the JPEG file or the HTML file back to the client. So it also needs to take another RTT time, right? However, you can see that there is a time right here. Because for RTT time, there's a specific definition right here. RTT time is a time for a small packet transfer from source to destination and then from destination back to the source, right? So if the packet is quite small, so the transmission time is negligible, because maybe the small packet is, for example, less than 10 bytes, something like that. So the transmission time is negligible. But right here, the HTTP response message that carries, for example, an image. An image could be, for example, 1 megabit, which is not negligible. So we draw it. There should be a transmission time. Transmission delay, because it has to spend some time to transmit 1 megabits response message, for example, an image in this message. Okay, so when you use non-persistent HTTP to retrieve an object, it needs two RTT. One is for initiation, the other is for transmit the exact message. And again, it needs some time to transmit the object itself. So it takes that much time to transfer one single object from the server to client. So as you know, if you have 11 objects need to retrieve from the server to client, you need 11 times of 2 RTT plus the transmission time. So it is very inefficient, right? It is very inefficient. So for the later HTTP 1.1, okay, we have some very nice design right here. If you have multiple objects need to be transferred from the server to the client, and then you can simply just set up one single TCP connection, and then you continue to request and receive the corresponding objects using that single TCP connection. You don't have to close it, right? That is more efficient. I think it is quite clearly if you take a look at this figure, right? Because browser often open at the right hand side, okay? That is persistent, okay? Because server leaves connection open after sending the response. So subsequent HTTP message between the same client and server will use this open connection. So a client sends the request as soon as it encounters a reference object. So the following object can be transferred from the server to the client. So as little as 1 RTT for all the reference objects, right? Cutting response time in half. So that is the design of persistent HTTP. And currently in our browser, we usually use HTTP 1.1, which is persistent HTTP. We don't use HTTP 1.0 anymore because efficiency is important, right? Okay, right here, we would like to introduce what exactly the MSG sent from the browser to the server. Okay, so that is HTTP request message. And usually it has 4 different parts. First one is called request line. So it is a single line. And very important thing is right here, all the HTTP message are encoded by ASCII, which is a human readable format. I believe you have already know what is ASCII table, right? So basically, this first line is the request line of an HTTP request message. It can be divided into several different fields. The first one is the method. And there's a white space right here. And the second part is URL, white space. And third part is the version. And that part is return character and the line field character. So these different fields combine them together. They are request line. And of course, there are several different methods we'll talk about later. Get means I would like to retrieve the resources written in the URL field. For example, it is an index.html file. I would like to get this URL file by using HTTP 1.1. Okay? \r/n, there are 2 ASCII control code. Okay, it's right here. It is number 13 and number 10 in ASCII table. They are simply just means enter. Okay? For simplicity, that simply just means enter. So from line number 2 to right here, it's the second part of the HTTP request message. They are header lines. So HTTP protocol defines several tons of header lines, but basically they looks like this: a name, including this one, and a space, and a value right here, and again a enter. That means when it's sent, it means the client. Right? When client send this request to the server, it has to show which host the client would like to connect it to. And again, what is the software used by this client, which is called user agent. And here, right here, the accept means what is the capability of this browser when it receives the response message. So let's take a look at these lines one by one. Okay, the first is host. That means the client wants to contact with www.net.cs.umass.edu. And the user agent, which means the client itself, is a Firefox, right? It is a browser, and it is on an Macintosh, an Intel Mac OS X 10.15, something like that. Okay, so accept, there are 3 different accept right here. Accept means I would like to retrieve the URL, which is index.html. But when you send these resources back to me, I only accept HTML format or XML format. Okay, I only accept these 2 different formats, either HTML or XML. And the language used in the HTML or XML should be English. Okay, Q 0.5 we will show you how to figure out what Q means. Okay, and then the encoding, that means, as we mentioned before, in application layer you can compress or encrypt your message by yourself. Then the accept encoding means when I receive the index.html file, the server can compress this file by using gzip, which is a compression tool. Okay, or you can simply just send me the flat file. Okay, so that is the capability that announced by the client. Okay, the last one is connection. The value is keep alive. That means we would like to use persistent HTTP. So please keep alive, because I will use the same socket, use the same TCP connection, connect to the server again to retrieve the additional referenced object. So that is the second part. The third part is relatively easy because it is an additional enter right here. And the fourth part is body. But in this example, there's no message in this body. So that this from the G to the next /n, that is the entire HTTP request message. For example, that is just an example. Okay. The reason why we use text-based, ASCII-based characters to build an HTTP message, that's it, because as you can see that in those different headers, the value of these headers might be variable length, right? So if you use binary based field, for example, the first method should have 3 or 4 bytes, right? And the following URL should be 100 bytes. They are fixed values. So it is not convenient to use binary based encoding method to write down all these HTTP requests. It is much more easier to use ASCII based or text based, because you know every line will end with an enter. So when the server receives such kind of HTTP request, the parser at the server, okay, the first thing is to read the entire line until the enter. And for the first line, there should be 4 fields, right? The method, URL, version, and the last one is the enter. Okay, so between method and URL and version, there should be 1 white space. So it is very easy for the server to parse the information content in the message. So, and again, the header lines is quite easy because each line is 1 header. And for the header, they seek for the first blank white space. So they know which header it is, and what is the value of this header, and this value can be variable length, so on and so forth, so on and so forth. So it is very flexible and easy to add additional headers in HTTP request messages. So that is HTTP. Okay, so it is a general format, very simple, very similar to what I explained before. We have a request line, right? We have method. SP stands for white space. Okay, URL, version, header fields, value, and additional. So that is second part. That's the first part. That's the third part. That's the fourth part. And every line ends with CRLF, which is the enter. Okay, and of course, let's talk about this one. And of course, usually we use GET, which is get, to retrieve the resources from the web server, right? However, there are some other interesting request message. Okay, get and post, head and put. Okay, we have mentioned get before, but here I would like to say something about something more about get. As you can see that GET, these three characters should be exactly the same, because the protocol says that GET should be GET. It cannot be any other words. Okay, the URL right here, that's very interesting, because they do not. The protocol do not. The protocol does not does not have any constraint to how long the URL could be. So basically, it can be very short, or it can be very long. For example, hundreds of bytes or even thousands of bytes can be placed in this URL field. But for the other headers, they have their own format and syntax. Okay, for example, right here, for example, accept languages. There is a list of languages in HTTP protocol. You can only use the language specified in the protocol standards. You cannot place any arbitrary language right here. So you have to follow the rules, you have to follow the protocols. But you can put any arbitrary characters in the URL field, because URL field does not have any constraint. So because of this reason, if the client want to pass additional information to the server, one of the ways looks like this. I believe you have seen it in your browser URL line, right? Some URL will be very, very, very long, because there are additional parameters that the client want to pass to the server, but there's no other field or place can put the additional parameters. So they put it in the URL field. So it looks like this. Usually there will be a question mark and end. The information after the question mark is the information that the server, that the client would like to send to the server, and the end will be the delineation. Okay, so that means there's an additional value which names Q, and the value is a computer network that the client wants to send to the server, and the source HP, OQ, blah 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 blah, something like that. So that is one of the way you can send additional information in the URL field. Okay, okay. So that is not that convenient. So we have another way, which is post. Okay, so let's take a look at the post message on the internet. Okay, HTTP post message, and we simply just randomly select some messages, right? Okay, for example, Okay, I think that is good enough. As you can see at the right hand side, okay, we have we have a post message. So the first 4 bytes are POST, right? And here is the second part. The red one is the request header. And you can see there are several request header. And you can see if we use post, there will be an additional header, which is content length. In this example, it is 345. That means there are additional 345 bytes are concatenated after the third part, which is in the body, the fourth part. So there will be 345 bytes in the fourth part that the client would like to send to the server. There's some additional information. So you can use post to send such kind of information. We can see, maybe we can see some. That is another example, right? The method is post. Okay, the URL is registerstudent.asp, right? So in the middle, there are several lines. They are section 2, right? They are headers. And at the end, you can see that there's a message body called URL equals to John and path equals to Java. And usually, you can set any arbitrary format in the message body when you send a post, as long as server knows how to parse the information in the body. Okay, it can be any arbitrary ASCII letters. Okay, so that is one of the. So that is another example. Post the message, content length 44 bytes, and in the following there are 44 bytes. They are simply just plain text that the sender, that the client want to send to the server. Okay, so we have 2 different ways to transfer additional parameters from client to server. One is post. We use the body to transfer the additional information, and the other is use get, because the gets URL has no limited size, so you can put a lot of information in the URL. Okay, at the right hand side is head and put, but usually we don't use head and put anymore in our regular communication. So the head means we send a message to the client. We send the message from the client to server, but the method is head. The server will not send the resource back to the client, only send the header back to the client. So the fourth part, the body part from the server back to the client is missing. Okay, but we don't use this quite often. Then put, we just simply just ignore it. Okay. Okay, we stop right here. That is the TCP request message. We will continue the response message next hour.